This is Mr. Townsend for Physical Science class.
And Miss Ray.
Today we're going to talk about minerals from Chapter 22, Section 2. It covers state benchmark E3.1.
So we're going to talk about rocks and minerals. A rock is going to be a solid composition of minerals, for example, granite.
And a mineral is more like a natural occurring thing. It's not going to be a rock, but it might be in a rock. And it's going to have unique characteristics.
So what's the difference between a rock and a mineral?
Well, I think a rock would have a mineral in it. And a mineral may appear to be a rock, but it would all be the same.
Oh, so minerals are kind of like pure, they're kind of the ingredients for rocks then.
That's a good way of putting it.
Okay.
Now, one of the things we need to do is to determine what type of mineral we have. And so there's properties we go over. Ms. Ray, what are some of these properties?
Well, one of the first properties we can look at is the crystal structure, which is just talking about the structure of how the atoms are put together, how they're arranged in that mineral.
If I just found a rock laying in the middle of the woods, would I be able to see its crystal structure?
You could not, because you can't see the atoms. You'd have to look under a microscope to see that.
Okay. What's another thing that we can look at?
Next, one of the easiest things to see is the color, which, straightforward, it's telling you what color the mineral is.
So this is the kind of thing that you look at if you're picking out jewelry.
Yes. We all like the clear diamond colored.
Not we all.
Okay. And another thing that we can look at is the streak, where we are actually looking at the color of the streak that's made when you scratch a rock on a porcelain plate.
Wouldn't the color of the streak be the same thing as the color of the mineral?
You know, Mr. Townsend, I would think so. You might think that, but actually some of the rocks can actually produce a different colored streak than what color it is.
Interesting.
So, and then you can also look at luster, which is a super fancy way to describe how the surface reflects light. And the easiest way to remember that is basically how shiny it is.
So this picture here to the right shows that's got to be gold there, right? Because it's got a lot of luster and it's got the color of gold.
It looks shiny like gold, but we would have to do some other tests to see if it had the same other properties. Test the streak, the density, do all that kind of stuff for
Why?
it.
It looks like gold. It must be. What else could it be?
You could also, it could be pyrite, it could be other things sometimes look the same, but they're made up of different compounds.
So I can't tell what mineral it is just by looking at it.
Nope. Only if you're a super scientist.
Well, I'm not there yet. And density means how much of the material there is, right? Kind of, it would almost be a weight kind of a thing if you had the same size sample.
Yes, that's exactly what it is. You just have to, the easiest thing is to compare weight, but you have to make sure you have the same size. So it's how much weight per size.
Well, that makes sense.
Yeah. And one of the last properties is hardness, where we're going to use the minerals. We're going to scratch one mineral with the other. Whichever one can scratch into the other one, that one's going to be harder.
So I heard that diamonds are the hardest material on Earth, so they would be able to scratch all the other types of minerals there are?
That is completely true.
Interesting.
And then talc, you can see down at the one side of it, that's one of the softest ones. Very similar to, think of chalk. That's very easy to scratch. You can even scratch that with your fingernail.
That's the stuff that LeBron James, I think, throws up before he starts his game in the year. Got a little talcum powder.
Oh, yeah. Talcum powder. That makes sense.
Fracture and cleavage. Rocks and minerals can break.
They sure can. And they break in, the way that it breaks is going to be the fracture. And cleavage, if it breaks flat, if you have a flat surface, that's going to be the cleavage. Where you can have it flat on both sides, which would be one directional. An example of that might be muscovite, you can see here. And it can break in 2, 3, or even more directions. And you can see, for example, on the side here, breaking in different planes, you're going to have it starts to look more cube-like.
And then some rocks just break randomly. They don't break in straight lines, is what this is saying?
Yeah, those rocks that are just kind of jaggedy, the ones that we usually think about, that's just going to be a not a cleavage fracture, but just a general fracture.
So all seven of the categories, every mineral's properties fall into all seven of those categories?
You can find all seven of the categories. There's going to be a part of it for the properties. You're going to have cleavage for everything. It might be zero cleavage, but you're going to have some kind of cleavage, some kind of fracture, some kind of hardness, and you can use those. You can use one of these charts to compare the things that you know for an unknown to all of the categories that we know for all of the minerals out there.
So if I found a shiny rock, a shiny yellow mineral in a little creek in the mountains, I could come and look at this chart and test that rock out to determine whether it was gold or not?
You betcha. And you definitely would want to test that before you went and tried to spend it as money, right?
Unless I could find some sucker to buy it.
Maybe. Maybe you can test your rocks just to see, try to find the fool's gold and try to get a fool to buy it.
I could do that.
All right. And so that is mineral properties. And if you have any questions, please pause the video and ask your teacher.
Thanks. Suspend.